So can everybody see my screen?
Yeah.
Yes, we can.
Thanks. Yeah, thanks for your time to come to this summit to chat about the knowledge graph. So yeah, I feel honored that I can give the opportunity to share and introduce how we are going to build and use knowledge graph in Pinterest. So actually, at the moment, the knowledge graph in Pinterest actually we can call it a taxonomy in a more accurate way. That the reason is that our knowledge graph is still a single tree structure. We only have single parents for single node, and for the edge type, we only have one single edge type, which is just a subclass to describe the relationship between the child and parents. At the moment, this is the only taxonomy and knowledge graph that is used in Pinterest, covering major use cases in many orgs in Pinterest. So later on, I will go to more detailed applications for how the interest taxonomy is used in various surfaces. Then for each interest taxonomy node, we attach different properties, like this node is not allowed for as showing. So this is the basic structure of the interest taxonomy that we are using in Pinterest today. So at the moment, in terms of the size of the taxonomy, we have 28,000 nodes. We have 20 plus L1, which is most general and fundamental level that covers broad verticals of the Pinterest contents. And we have up to 11 levels with more granular terms under these L1s. So for international taxonomy, we currently supporting 19 languages of the international taxonomy. So for the international taxonomy, we exactly have the same structure and the same the number of nodes. We just use English taxonomy as the ground truth and do the translations to construct all these international taxonomies that we can support various kind of market and business needs in our international markets. So in today's presentation, I just want to mainly focusing on 4 areas. So the first thing is that how we are building the interest taxonomy, then followed by how we are building it. And in the third part, I will also talk about what kind of downstream machine learning signals we are building, because we find that if we only provide the taxonomy and knowledge graph itself, it looks like the impact is not big enough. If together with this downstream signals, we can create more end-to-end impact on our pinners as well as other areas. Then last but not least, I will conclude the several major projects we are going to execute in next year. So why do we need the interest taxonomy in Pinterest? Okay, so the first major surface area is the growth. So here I just get this Pinterest web page. This is for engaging the new users. So you can see that the interest taxonomy exposed to the new users without the logins on Pinterest website. So the interest taxonomy is used to categorize the most engaged pins in different nodes that represent the most popular concepts and ideas in Pinterest. So taxonomy hierarchy are also used to link different pages so that the after pinner engage into one of the pages per interest node, then they can keep on engaging in different pages with similar interest. Then, in addition to this web page, the new users can also pick up their interest, following an interest, as well as receive the email notifications. So, in addition to the interaction with the users on the UI, the interest taxonomy also plays a very important role for the user engagement in the backend. So in our home feed, the ecosystem, the interest taxonomy actually is used as a index to categorize both pins and users. So for example, for pins, we use together with the downstream signals, we categorize pins into different nodes of the taxonomy for for both the users with the engagement history as well as the new users. And on the user side, based on the user engagement, or if the user don't have any engagement, then we will just retrieve the most engaging pins for the users. Then interest taxonomy is used as a bridge to connect the pins as well as the users. Then this kind of backend recommendation system, we use them in a lot of applications. So one example is the recommended topics. So we just recommend recommend the interest node as well as the pins to users. Then the second application is the creator IDC. Because at the moment we are trying to promote the creator fresh contents, then we also use this recommendation pipeline for these purposes. Then in ads, we show the interest taxonomy to advertisers, so advertiser can pick up the interest nodes for the targeting purposes. And the last but not least, the interest taxonomy is also used in the product search. So this is a snapshot of the visual search products. So here you can find that those shoppable objects like chairs, walls, coffee tables, right, are captured by our visual engines. So then when you click them, there will be similar shopping items show up in the next pages. So again, all these categories actually are powered by our interest taxonomy now. Then these are the major applications of our interest taxonomy in Pinterest. Then the next question is that how we are going to build and maintain it. So all the taxonomy-related development work is based on this fundamental data modeling, which is called the LDAP, where the key thing is that each relationship is modeled as a triplet, which contains the relationship itself as well as the two entities that has this relationship. And for tooling, we are using open source software called WebProtege that is developed by Stanford team. So the reason why we are choosing this tool is because in terms of scalability, since at the moment we don't have such a large size of the taxonomy and data, then this tool actually is very suitable for small data size that is modeled by using the RDF. Also, the visualization and curation is easy on UI. It supports the concurrent editing. Also, we also find that it's easy to write the pipelines to dump the data or import the data. However, one one shortcoming actually we found that is about the data privacy, because if you are using this tool, then all the data will be hosted outside our company. Then as you know that some of those in the taxonomy actually is very sensitive. So in order to make sure that the data privacy is secured, we actually built a private instance with LDAP login authentications. So to make sure that the access to the interest taxonomy is protected. And for the work using WebProtege into the taxonomy development at Pinterest, we also got a best paper in ISWC 2019. Then, as just now as Kati mentioned, building up a taxonomy, well, is manageable. But actually the question is that how we are going to maintain it and update it. So as you know that in Pinterest, the contents every day will be different, right? Every day we have new concepts, we have new things happening in the world every day, right? So how to make sure that our interest taxonomy can be dynamically updated in a timely manner is super important for us. So for at the moment, we have an auto taxonomy expansion pipeline that is in production for this need. So the logic is that we can let the user ad hoc request new nodes adding in UI, and we also search for the new trending terms. So this will be used as a candidate. Then after that, we have the machine learning algorithm to try to map these new terms to either the existing nodes or creating a new nodes and suggest the parents for them. Then after that, we have the human confirmation before we finalize the taxonomy in WebProtege. So this is the only part that human interferes in the whole process. Then after the new taxonomy is finalized, then we will update various kind of tables and online storage in production. Then the last part is that we will also do the auto update for the downstream machine learning signals. So here the trick for auto update downstream signal is that the first of all, this expansion will seldom touch the L1, L2s. We mainly try to curate new nodes for more granular concepts. So this will make sure that the downstream signal update is stable in this automatic way. Then the second thing is that most of our downstream machine learning signals, actually we are using some search models to calculate the relevant store. So as long as we can just update the candidate generation part, then the whole signal can be just updated for the new taxonomy. So in this way, yeah, we can also make sure that if there's no big change on the current existing taxonomy, we can always do the auto update for the downstream machine learning signals. That can save a lot of tuning time for us.
1 minute.
Okay, thanks. Okay, yeah. So the machine learning algorithms we use for mapping the terms to the taxonomy nodes or suggesting parents for the new nodes. We have developed in-house algorithms. So I think the difference comparing to most of the papers in the literature is that because we know that there are a lot of papers describing how we are going to model the single age type. But however, in Pinterest, we only have one edge tab. But different branches, they have so many different semantics. So that makes the prediction problem different. Then we have this paper try to solve this issue and make the mapping and projection easier. Okay, so I just so last but not least, I just want to touch the downstream signal. So just now I mentioned that the taxonomy will be more powerful when we have downstream machine learning signals together used with the taxonomy. So at the moment, we have several downstream signals like pin to interest. So we map pins and categorize pins into the interest taxonomy. We also have the bar to interest, which means that we also do the categorization on boards, as well as the pinners, as well as queries. Then recently we also make the synonym in production. So in synonym, we just try to find those terms that with the same context as those nodes in the interest taxonomy for applications such as entity matching. Then in 2021, so here are the major projects we are going to execute. So the major goal for 2021 is that we want to transform the taxonomy to really a knowledge graph. We support multiple parents, and we are building more connections among the nodes. In addition, just to the single parent to child relationship. We also will create a subviews to optimize the experience for different organizations and Pinterest, because different organizations they will have a different request, and they may not want to use all the nodes in the taxonomy. So how to optimize the experience for them is super important, and make sure that those subviews are consistent with the main taxonomy. Then the last but not least, we also want to leverage the interest graph to infer the entity relationship that can power the product recommendations as well as the creator recommendations. So yeah, that's all for my presentation. I just want to thank the whole taxonomy team and support from Ray on all these projects that we have done and those projects in 2021. Thank you very much.
All right, thanks, Song. Right, hope you get a rough idea of how we built the interest graph at Pinterest and how we leverage for various recommendation and ads modules. Any questions? Hi, Mike.
I do. I have lots of questions, always.
Great.
So, Song, the subviews that you mentioned, how are you thinking of partitioning the graph or the tree for different use cases?
Yeah, so at the moment, what I'm thinking is that so this subview is mainly just let the organizations, they just choose a selected number of nodes in the main taxonomy. Then
nodes generally, or is it by level? Because the requests that we get are usually by level. So
yeah, so
we only want to see L1 and L2, and the rest we don't care about, that sort of thing.
Yeah, so actually for our first use case of subview, actually they also request the level as well. So basically in this subview, actually you can think this is a small tree.
Right.
That's out of a big main taxonomy tree.
So they don't want it vertically by branch. They want it by level.
Well, so in our first use case of taxonomy subview, they have covered a couple of verticals. Then in each vertical, they also have the hierarchy. So for example, like a fashion, right? So
okay, so that's what I would call by branch.
Okay, got it.
Okay, I'm raising this because when we get these requests by level, then what happens is we constantly get complaints about at L2, the things that we see in this branch don't look like this. They're the same level of generality at the L2s in this other branch. And they think that that's weird. The clients, our clients.
Yeah, that's exactly the request we are receiving as well. So in that case, in order to support this subview, then we should allow the node to have multiple parents, because in this subview, they may prefer that, okay, this node, yeah, we need to attach this node to some other branches, right? Then in the main taxonomy,
yes, that's another kind of subview where the structure
Yeah.
is changed around. So I'm asking about the feedback that we get about granularity. So they say that the items on L2 don't look like they're the same level of granularity, and for me, that's an impossible thing to fix. I have no idea how to fix it. That's why I'm asking.
Yeah, I can actually shed a little bit of light on this.
Okay.
So for instance, for ads use case, we expose part of our taxonomy for ads targeting.
Right.
So ads PMs actually came in, reviewed the whole taxonomy, and handpicked a subset. So that means for some branch, they pick up to L2, and for some branches, they pick up to L4. So it depends on how they feel the advertisers are interested.
Can I say something?
Of course.
You're very lucky.
Why?
So our ads people will only complain. Okay, they said that's not how we want it. So for you to have people who come in and help you choose means you're lucky.
Thank you. Yeah. Yeah, we had a good PM from ads targeting that year. So we're really lucky. Yeah. So for the other use case, if they want to onboard quickly, they will pick, okay, so we'll target L1, L2. Okay. Yep. So if they're not satisfied with that selection, then they will want to spend more time and hand create a subset. Yeah. That's how it is nowadays.
Okay. That's good.
I have, Mike, are you done or?
Yes.
Okay, thank you. So yeah, really interesting presentation, Sang. Two questions. One is on the taxonomy alignment across different languages, different countries, right? I understand you guys are translating, right? So essentially you're maintaining a one-to-one mapping, right? But is that always the best thing to do?
So are you saying that is it valuable to customize those international taxonomy?
Yeah.
I think in the past we received such a request, but however we don't have a very solid use case that we see the value into doing this. Yeah, probably later on, let's say if we expand into those international markets in a more deeper way, then we might find it valuable. But at the moment, we don't think this is a valuable thing that we need to pursue.
And we have the same experience. So we often got questions along the same lines as Joe's question, but we couldn't find any really key examples to motivate doing separate taxonomies for different languages.
Okay. Then you guys are lucky, because at eBay, different size, right? The shape of the tree are kind of different, right? They align at a large level, but not every single detail, which is itself is challenging.
Can you give us some examples? Because like I said, we couldn't find any, and Sung couldn't find any examples that would motivate separate trees.
I think in UK and US, right, people have different expectation of certain listings and items, right? So over time, they evolve into different structure. Okay, I can give you some concrete examples of
Okay, that'd be very helpful.
Just to add in something, even on the edtech side, we are building. We serve the Middle East, which is Arabic, and South Asia, India, in English. Our concept graph is going to be in one language, English.
Okay. Yeah. If you can keep it that way, by all means, do that.
Exactly.
Exactly.
Simplifies a lot of things.
Exactly.
Yeah.
This is why I'm interested. This is why I'm interested in your examples, so I can be prepared for a good response if someone uses them.
Right. My second question is, when you map pins users, right, to the nodes in the in your hierarchy, in your taxonomy or graph, right? Do you focus on leaf level, or do you also map it to the parent level?
On terminals.
Yeah.
Yeah, we map to all the levels, but however, let's say for a single user, they may categorize into multiple nodes. We are not necessary to limit the user mapping to just one node.
Okay.
But we still find that some of the use cases that require we map those entities into all the possible nodes in all the hierarchies.
Right. Okay. Yep. Got it.
That reminds me of another question. Okay, you can go, Karthik.
No, it's fine. It's fine. I'll go after you. It's okay.
Okay, so you mentioned the board to interest mappings.
Yeah, sure.
Do you use those to validate your taxonomy? Because what you're getting is a folksonomy from the users when they put these pins in this board. Have you used that to validate your classification in the taxonomy?
You mean whether the hierarchy is all right?
Whether the hierarchy in the taxonomy matches the hierarchy that the users made by putting pins into boards, which are categories.
Oh, okay. Yeah, that's a good question. I think this is something we haven't done yet. Right.
Okay.
So in fact, I think there's a slide that because of the time Song skipped, it's a candidate generation for the auto taxonomy. So one type of candidate is actually board section pairs.
Okay.
So we allow pinners to create a board, then create sections in the board. So that automatically gives us some hierarchy information.
Yes.
So we leverage that as one type of candidate. So in that sense, we do validate based on board information. Yes.
Yeah. So we often find that we get this when our taxonomists focus on a domain. They come up with a classification that's not always the same as the classification that the users would prefer. So there's a mismatch there between the classifications sometimes.
Yeah. Thanks, Mike. Karthik, your question?
Yeah, I had a question around the data model. You guys had picked RDF, and twice in my career I have, moved out of RDF to LPG. So I would like to understand, your perspective on that.
Yeah, I was waiting for somebody to raise that question. Okay, so maybe I can answer that one because I made that decision at the first phase. Yeah, so we pick RDF mainly because it's standard, so we can easily combine our own data with external public data because most of them are in RDF format. Because we're capturing like a broad concept, so we can leverage Wikipedia data, all the other external data. So that's the major motivation. And the secondly is to leverage the WebProtege, which is based off RDF as our tooling.
Got it. Yeah. Thank you.
So my question is, why did you pick the property graph over RDF?
Yeah. Sure. So basically, I didn't have this constraint of Prodigy, one, and we had at Walmart we had our own tool to manage taxonomy, and even here, we're not on Prodigy. So the main motivation for LPG was the fact that you could actually add properties to your edges. And over a period of time, what we have realized is that the interesting part about graph is capturing those relationships and enriching those relationships. Lot of the querying actually happens on those filters. And that is something that LPG became super easy to do. Just throw in a JSON, and then you can actually write gremlin queries, or depending on what your database provides, you can actually do a lot of querying on that. So that makes it super easy. Yeah.
Yeah, the property on the edge is a huge advantage of the property.
Exactly, exactly.
Yeah.
Yeah, but with RDF, if you take the quad model, you can do more or less the same thing.
Yep. Cool. All right. Thank you. I think we are at our break time.
Let's come back in 5.
I'll come back in 5.
Let's do that.
Let's do that. So we see each other in